This video demonstrates static routing and network address translation in the context of a redundant router configuration. In this network, the redundant routers use Cisco's hot standby routing protocol to determine which router will connect the local area network to the edge router. Hot standby routing protocol, HSRP, is covered in the CCNA 7.0 Switching, Routing, and Wireless Essentials coursework. An HSRP version 1 router can either be the active router or a standby router. The function of the HSRP standby router is to monitor the operational status of the HSRP group and to forward packets if elected to be the active router if the active router fails. An HSRP group provides a virtual MAC address to the local area network host machines. With HSRP version 1, this virtual MAC address value is 0000C07ACXX, where XX is the standby group number. So if the configured standby group number is 05, then the MAC address of the local area network default gateway would be 00000C 07AC05. This virtual MAC address will be viewed in the ARP cache of host PC0 in the packet tracer network we're about to explore. The objectives of this network are first, to practice configuring IP address settings on router interfaces and on host machines, and then to demonstrate both the configuration and use of static routing and network address translation / port address translation. We want to introduce and demonstrate hot standby routing, a redundancy technique that will be covered in the Switching, Routing, and Wireless Essentials Cisco course. We want to produce routing tables and analyze those routing tables. And we want to demonstrate a brief exercise in troubleshooting. Student instructions are as follows. After studying this video, students will be able to do the following. Configure IP addressing on all router interfaces and host machines in this network. Configure the appropriate static routing on the 3 inside routers, Edge, HSRP0, and HSRP1. Configure network address translation / port address translation on the Edge router. See the NatPat configuration text box in the packet tracer file. Then we want to add the standby routing configuration on both HSRP routers. See the HSRP v1 configuration text box in the packet tracer file. Students will then view and understand each entry in the routing tables on Edge, HSRP0, and HSRP1, R1. And then students will evaluate and comment on the impact of deleting individual static route configuration statements. For example, deleting a statement off of the Edge router will result in a destination host unreachable. We want to understand why that's the case. Now let's put the configuration in our network. First, we'll look at our 2 host machines, our PC0. Notice the virtual router is the default gateway. You'll see that there is no 10.0.0.62 anywhere on the network except in the virtual router configuration. And our server is configured as well. Our switch S0 gets no configuration. All ports are members of VLAN 1. HSRP router 0 will get this configuration here. G01 is connected to the edge router. The address is 5.1.5.1. G00 is connected to the multiple access network, our local area network, and that'll get .39. It's a /27 subnet. And then for G00, we'll configure it as a member of standby group 5, and it will carry the virtual address of .62, which will be used as, again, the default gateway for the local area network. And we will enable preemption, which means if another router gets if this router gets a higher priority, or if the other router goes down, this will take over. Actually, preemption means if this gets a higher priority, this will take over. It will automatically take over if the other router goes down, whether or not preemption is enabled. Check for errors. Now HSRP router 1 a few notes about this configuration once after we put this in. We see we have some errors. Let's find out why. The standby configuration has to be configured as part of the interface configuration. And we have the exit command in here, so that has to be deleted. So now we can go ahead and put this in again for R1. And now we'll see the comment here, configuring the standby router at 120 will result in this router being elected. They've already done the HSRP communication. And it even goes on to say the other active router, is priority is not configured. Now when we configured R0, the hot standby router routing protocol was not set, and so it was given the default priority of 100. You'll notice that we have not configured any static routing yet. Let's put our configuration in Edge. Just the routing the interface configurations. Okay. Check for errors. And now we have to configure our ISP, which again just gets interfaces configured. We see all of our interfaces appear to be up. Show IP interface brief. We're all up there. And we're all up there. And there. And here, we're all up. Okay, our next step is we want to configure network address translation on our edge router. Here's our NAT line. We have network address, or NAT inside and the NAT outside areas defined here by these labels. So this whole area in here will be NAT inside, but the only address space that we're going to translate is the multiple access address space, the 10.0.0.32/27. can see here we're going to specify G00 as NAT inside. G01 is NAT inside as well, these two interfaces. G02 will get the outside designation. We'll have a standard access list that permits address space 10.0.0.32 with an inverted mask or wildcard mask of .31. And then we'll specify this access list in our IPNet inside source statement. IPNet inside source list 7, interface G02, which is this outside interface. Overload will activate the port address translation within the edge router, where it specifies its own source port to make each conversation coming out of that router interface unique. And remember, you have to hit enter if you have an orphan so that this line gets executed, otherwise it does not get interpreted. Now, if we look at our routing tables and show IP route, you can see that Edge has no knowledge of the 209.165.200 network. It also has no knowledge of the 10.0.0.32 subnet. So static routing is needed for both of these. If you look at HSRP R0, this router has no knowledge of anything beyond the two networks to which it is connected. So in HSRP 0 and HSRP 1, we're going to add the default route, which simply says go to the edge router if you get a network that you don't have in your routing table. So configure terminal, IP route. Now we're on HSRP R0, so we're going to specify .5.2 as our next hop. On HSRP R1, we have a similar configuration statement. And there our next hop will be .6, 10.0.5.6. Now if we look at Edge's routing table, the routing table of HSRP R1, show IP route, we can see now we have a candidate default route that was installed as a static route that says if we get a destination network that is not listed here, then it will send that packet to 10.0.5.6 from R1. Now Edge, we have to configure some static routing on Edge. It's important to note that this is the default static route that we configured on both of these HSRP routers. Back to Edge. Edge has no knowledge of the 10.0.32 subnet. It can get there two ways, and we're going to configure both mechanisms, both paths. It's going to get there via 10.0.5.1 or .6. Oops, .5. There we go. Now if we do a show IP route on the Edge router, we can see it now has knowledge of the .32 subnet, and it has two entries in the routing table. One, it's going to use the .5.1 path, and the other .5.5 path. Because they both have the same administrative distance and cost factor, the router will do what's known as equal load balancing. These will share the load, these two paths, and we'll demonstrate that in packet tracer simulation mode. Now you also see that the edge router has no knowledge of the 209.165.200 subnet, which is where our ISP is connected out to the internet. So our connection to the ISP is this public address space, 209.165.100. We still need to get out here. So we're going to configure an IP route for that. IP route, no. And that's just our ISP. You have to be careful stacking default route statements as we're doing here. You have to make sure that they're not going to put you into a loop. Okay, now, why does the ISP not need any static routing? All the ISP can see is the networks to which it is directly connected. And the answer lies here on the edge router. We have configured the default route, we have configured the network address translation to use whatever address is configured on G02 for all traffic leaving the edge router. And that address is the 100.2 address, 209.165.100.2. This network uses a NatPat configuration. How this NatPat configuration alleviates the need for the ISP router to have knowledge of the address space inside of the edge router is the subject of the following explanation. Network address translation uses an inside local address space and an inside global address value. In this NatPat configuration, the inside local address space is 10.0.0.32/27 and the inside global address value is 209.165.100.2. For all outgoing packets sent from the inside local address space, the edge router will translate the source IP address to the inside global address value 209.165.100.2. And according to the operation of port address translation, the PAT portion of NatPat, each outgoing packet stream is assigned a unique number which is appended to the inside global address value, thus making each packet stream unique. Therefore, in this configuration, the ISP router only needs knowledge of the network it shares with the edge router. No knowledge of addressing inside of the 209.165.100.2 address space is needed by the ISP. The show IP NAT translations command will provide a list of translations recently performed on the edge router as shown here. Here it's empty, and now we'll do a ping. And as that ping is occurring, let's do show IP NAT translations again. And now we can see the translations. We have the inside local address being the address of the host. Here's the unique integer for each packet stream. And here's the inside global value. Now let's test our network. We have ICMP ping enabled. First, let's look in this packet here, inspect it. And notice the source is .37 and the destination is .10. But if we look at our destination MAC address, it's that value we discussed earlier, 0000 0707 AC0505 because that's our group, our HSRP group ID. Now notice the path that the packet took back. Now let's watch the path again this next time. Now it takes the alternate path because of the load balancing factor. Now this time it'll take the path to the right on the way back. Okay, one more thing we want to see with these pings in terms of network address translation. If we inspect this packet here, there it is. If we look at the inbound value, it's .37. That's the host PC, PC0. That's the inbound source IP address. The destination is that server. If we look at the outbound PDU, we see that the source has now changed because of the network address translation doing its work. Now as the packet returns from the ISP, notice first of all the ISP, the destination IP address is the 100.2. But now that it's back at edge, we'll see network address translation doing its work. The inbound PDU has a destination of 100.2, but the outbound has been translated to 10.0.0.37. Notice the source IP is still the outside address 209.165.200.10. Now let's see what happens if we take out certain static routing statements. For example, in Edge, right now, if we look at the routing table here, you can see that we have knowledge of the .32 subnet. But if we take both of these static routing statements, the static routing statements that provide this entry, we'll see a different response in our ping. No IP route. Do show IP route. Now we see that we have no knowledge of the .32 subnets. So let's send that ping again. We'll fast forward time, and we get the request timed out. Now the request timed out because it got out of the network, but it never got back in. Let's watch it in the simulator. The packet gets out. But there's no reply. Just gets hung up going back and forth up here because the default route on Edge is set for the ISP. Now let's put those two routes back in. Verify that we have full connectivity again. And we do. Now let's see what happens if we take out the route, the static route out of HSRP or R0 and R1 that get us to edge. We're going to take out this static route on both of them. That's R1. And we'll do our ping. Now we get destination host unreachable because the packet can't leave the network. It gets hung up at R0 and R1, as we'll see in the simulator. Destination host unreachable. Now let's go ahead and fix those routers, put the configuration back in. And we'll verify our connectivity. We have connectivity to the external server out on the internet. And finally, let's demonstrate what's happening with our HSRP and show standby. This is the active router. R0, show standby. This one is in standby. Now if we bring this link down at port 23 in the switch, enable interface 23, we shut it down, we'll see that this is now the active router. We have the state change going from standby to active. So if we do show standby again, we see that this is now the active router. And then if we go into the simulation and ping, we'll see it will take this path. Earlier we saw it taking the R1 path. Now we have preemption enabled. So when we reactivate this interface, preemption will automatically bring R1 back as the active router. Out of simulation mode, back to real time. We're in our switch. Do a no shut on this interface. Fast forward time, so spanning tree will finish its work. And we'll go back into the simulation. Well, first of all, let's look at R1. And we can see that it's gone back from standby to active. Well, speaking first because that's part of the progression of going to active mode. And this has now gone to standby mode, R0. And we can see R1 is now our active router again. Demonstrate that. We see that router R1 became the active HSRP router by preemption when port fast Ethernet 23 on the switch was brought back up. We also see equal load balancing occurring on the edge router as it equally distributes the ping reply packets between R0 and R1. If you are a student, be sure to answer the 5 summary questions and produce this network using Packet Tracer. Thank you for viewing this video.